This is an index card for you to make. It's got 4 columns. And it starts with 95%, 90%, 91%, 92%, 93%, goes all the way down to 99. And then you change the percent into a decimal, 0.9, 0.91, 0.92, 0.93. And I'll explain everything else. Just write everything down.
Is exam 3 and the final both due on the 3rd?
Exam 3, exam 4, and exam 5 all have dates. They should be on my lab flip math.
Mr. Hubert.
Yes.
I only see exam 3 on my Labs Plus. I don't know if I'm blind because I usually miss a lot of stuff. But
Well, I haven't put this last one, chapter 9.
I'm
gonna put it up when we finish the material.
Oh, okay, gotcha.
Yeah.
Does that say component of X at the top?
Complement.
Okay.
And that's not X. That is called alpha. It looks like a fish. Looks like a fish pointing to the left. It's the Greek letter alpha. And the third column says area, says alpha over 2. And the last column says inverse norm, z sub alpha over 2.
Did you get my message about not having access to that stuff earlier?
Yeah, I have no idea how to fix that because you should have access. You have access to, oh God, I can't even think of the name of it. Teams. You should have access. What did it say when you said, when you asked for access?
Request for permission for access.
I know, but what did it say after you applied for it?
Awaiting access approval.
Well, I'll have to put it on YouTube and send you that's all I can do.
Is that 2.58 on bottom C-score?
Yeah, 2.58.
And then this says inversion normal.
Inverse norm, z sub alpha over 2.
Z over 2.
Sub alpha over 2. That's that right there. Alpha over 2. Z sub alpha over 2.
Okay.
I know it's hard to see.
Yeah.
Actually, you can make it better when you put it on your index card. Now, why do I need to make this an index card? Because it'll save you a lot of time when you're doing the actual problem.
Son of a bitch.
Okay?
I done messed it all up.
How'd you mess it up?
Because I can't read. I done messed up my numbers.
Which numbers did you mess up?
My column. I had to start over. That area of alpha over 2.
Yeah. Well, hurry up. Take a minute and start over.
No, it's fine. I'll just try to write it down real quick. And you
No,
just
I'm gonna
keep
wait
moving.
until you finish, because I know somebody else probably messed up too.
Is that on the first one? It says CONF. What does that stand for?
Says, you're talking about, it says confidence level, percent.
Now, the complement of alpha. 0.1, 0.09, 0.08, 0.07, 0.06, 0.05, 0.04, 0.03, 0.02, 0.01. Now the area of alpha.
Over 2.
Point 0.0500, 0.0450, 0.0400, 0.0350, 0.0300, 0.02500. And then the last one you said inverse.
Says inverse norm,
Norm.
and Z, this is your Z score, Z sub alpha over 2. It matches up with this area. And I'll show y'all how to do this in just a second. As soon as everybody gets it written down, I'm going to start.
All right, I'm done.
Okay, now, does anybody notice the left side? I got it in yellow. That means that's going to be given. If you have a question on a test or homework, that number is going to be given. Why do I not have 100 on here? And that means I would have 100% confidence level. Why do I not have 100% confidence level?
Because nothing certain in math or
Because that would be what? If you had 100% confidence in your ability to do a math problem, that would be what? Starts with a P.
Perfect.
perfect.
Perfect. And there is no such thing as perfection in probability and statistics. That's just like saying impossible. So you leave off 100 because you're not going to walk into a meeting saying that you're 100% confident. All right? And I don't mean that in a self-improvement way. I mean it in a statistical way. Why don't I have 75% confidence level?
Good, not high enough.
Good job, Mr. Mance, because you don't want to walk into a meeting saying, oh, I'm about 75% confident in my math. You don't want to walk into a meeting with 75%. But since the homework and the test do ask and do randomly generate numbers, sometimes you may be asked for a 75% confidence level. And it drops off of this index card. How do you find it? Well, I'll show you. First thing you're going to be given is you're going to be given a confidence level. Given a confidence level. And I'm going to say 75%. Okay, so this is what's given. And the first thing you're going to do is you're going to write down P is equal to 0.75. I'm sorry. No, you're not. That's for another problem. I'm sorry. So your confidence level is 0.75. So that means alpha is equal to 0.25. So somebody tell me what alpha is in relation to the confidence level. Look at the math. Look at the numbers. Somebody tell me what alpha is in relation to the confidence level.
It's only a quarter.
Yeah, that's right. But it's something that we've talked about since chapter 3.
The complement.
Quartile.
Complement. Thank you. Complement. So the complement is alpha. And now you're going to take alpha and you're going to divide it by 2. And that's going to be your area. So 0.25 divided by 2 is going to be 0.1250.
Why do you always add a 0?
What?
Why do you always add a 0 to everything?
Because what is area? How many digits is area?
4.
4. Okay. And now inverse norm. Somebody take your calculator and do inverse norm for 1250.
The decimal or just 1250?
0.1250. There is no area that's above 1 because all our areas go from 0 to 1.
Negative 1.150.
What?
Negative 1.150.
1.15. Now we take the positive. We don't care about the negative because we're going to calculate it and we're going to use the positive. So that's how you do 75%. All right, I'm going to give you another one. I'm going to do 3 or 4 of these because these are 3 or 4 of the problems on your test. They're very simple. About point. Yeah. 0.82. Somebody tell me what the complement is to 0.82.
0.18.
0.18. Good job. And what's 0.18 divided by 2?
0.09.
Good job. And somebody put inverse norm, 0.0900, and give me the absolute value. I don't need the negative.
1.34.
Good job. Let's do 2 more. The reason I'm doing these is for 2 reasons. One, the homework regenerates, and they're not going to give you 90 to 99 confidence level every single problem. So, and the second reason is these are 10 test questions right here. There's 10 test questions right there. Given the yellow, the answer is the green. And here's 4 more. We're going to have 4 more. So let's do 0.70. What is the complement to 0.70?
0.30.
0.30. And 0.30 divided by 2 is 0.1500. And I need somebody to do inverse norm, 0.1500.
1.04.
Good. And the last one, 88%.
8.12.
So I'm going to let y'all do that one by yourself. 88%.
That's simple, no? One point.
So what is the complement of 0.88?
0.12.
And what is 0.12 divided by 2?
0.0600.
And the inverse norm of 0.0600?
1.55.
Okay, so on this page, you've got the 10 most used on homework and test. That's why I told you to put it on an index card.
No, I said 1.55.
1.55.
Yeah.
And along with the top 10, you got 4 more right there that shows you how to find the inverse norm, the z-score for a confidence level. And that's what this is. Finding a z-score for a confidence level. The confidence level will be given. The question will say, the confidence level is, or find blah, 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 based on a confidence level. And it will be given. And you, in order to do calculations, need to be able to find the Z for that confidence level. That's 3 or 4 questions on the test for Chapter 9. Okay? All right, now let's move on. Now here are the formulas, and here's what we're going to be finding in Chapter 9. We're going to be finding P hat. That's called P hat. It's got a little hat on top of it, just like the exponential. It's called the caret symbol. It's called P hat. P-H-A-T. P hat. And it's called a critical value. Now I'm not going to get into why it's called a critical value because we're not going to be getting into Chapter 10, so that's not really that important. But the difference between P and P hat is P is called a proportion and P hat is called a critical value. Is it the same thing? Yes. Is the decimal and a fraction the same thing? Yes. But sometimes they ask you to do a fraction and sometimes they ask you to do a decimal. So I'm just telling you, sometimes you'll see it as P, sometimes you'll see it as P hat. X over N. Since the first couple of weeks of class, or the first unit, What have I always told you about N?
It's always
N
the
is
largest
always your
number.
what?
Largest population number.
Your biggest number, yes. So if N is your biggest number, then X is going to be your smallest number. Now, P hat can come in form of a fraction. It can come in the form of a decimal. It can come in the form of an area, meaning 4 digits. It can come in the form of two numbers. X is equal to a number and N is equal to a number, and you have to put it in fractional form.
Oh boy.
Okay? Just like chapter 7. Now, if P hat is a number, then somebody tell me what Q hat is. Same thing as Q. It's always the what? The complement. So let's go through a little drill so we can put that behind us. P hat is equal to 0.75. Therefore, Q hat is equal to what?
0.25.
Okay. P hat is equal to 0.42. Q hat is equal to point what?
0.68.
0.58.
0.58.
All right, now I'm gonna do something special here. P hat is equal to 10 over 15. What is Q hat?
.6 something. Point.
You're starting with a fraction, bud. You end with a fraction. So if my fraction is 10 over 15, what is Q hat?
5 over 15.
I can't hear you. What?
I
5.
don't know how to do fractions.
I didn't see who that was that said that.
That'd be me.
No, somebody said the answer.
Noah.
I heard it again. I think he said 5. 5 over 15.
How do you get that?
Got to equal the whole. What's 1 with a fraction?
What?
What is 1 whole with a fraction?
Well, 101.
What?
I don't know. I don't know how to do fractions.
I know, but people are answering, but then I say what, and then they go, they just shut up. Okay? What is a whole number in terms of a fraction?
1 over 1.
1 over 1? Give me another example.
6 over 6. 4 over
Say
4.
it. Speak up, please.
5 over 5. 6 over 6.
6 over 6. What's another example of a whole number fraction?
5 over 5.
5 over 5. So if my denominator is 15, what's the whole number? What's 1 whole? 15 over 15. If 1 is 10, then what's the other one?
5.
5.
Is that because 5 plus 5 is 10?
There you go. 5 plus 10 is 15. Yes. Okay, so there's your P hat and Q hat. Now, who does not understand?
I'm here. I just don't.
Okay, you can't. You're telling me you don't understand what 0.25 is 0.75.
That I do understand, yes.
Okay,
But-
we do the same thing with a fraction. You've been doing it.
No, I haven't, not
Yes, you
fractions.
did. Chapter 3 test. Yes, you did. You did
I didn't.
exactly the same thing. I'll give you an example. This is what y'all did, and all of you did it with me. 1/4, 1/4, 1/4, and 1/4. Is that probability?
Yes.
Yes. Why?
They all equal a whole.
Because what? What is 1/4 plus 1/4 plus 1/4 plus 1/4? What is that?
Equal 1 or
It's equal what? 4/4.
4.
And anything over itself is equal to 1. So if you go back and you look here, what's the denominator?
15.
15. So the numerator has to equal what?
15.
15. So if this is 10, what is this?
5.
5. What's 10 plus 5?
15.
What's 15 over 15?
1.
1. So I'm going to do another one. P hat is equal to 6 over 10. Therefore, what is Q hat?
4/10.
Good job. And that's how you do the complement. P hat, Q hat. P hat, Q hat. P hat, Q hat. P hat, Q hat. Now, the good news is you usually don't have to worry about the fractions because you can change them into a decimal. But there are some questions on standardized tests that will give you a fraction and you need to find the complement. Okay, so there's P hat and Q hat. Next, and all this is going to come together in just a few minutes when I show you the formula that we're going to be using.
I was gonna say it can't be that easy.
We're going to be using the confidence interval or the confidence level dictates the confidence interval. Now, the confidence interval is what we're going to be finding. And the confidence interval is made up of two things. It's made up of P hat, and it's usually in the middle. And then to the right, you add what we call the margin of error. And to the left, you subtract the margin of error. Now, have y'all been doing this all semester? Yes. What have you been doing it with?
Empirical rule.
The mean and the what? Yes, the mean and the what?
Standard deviation.
Exactly. The mean is equal to 20 and the standard deviation is equal to 5. So that'd be a 25 and that'd be a 15. So y'all been doing this all semester. Which way do you do? What do you do to the right? You add. What do you do to the left? You subtract. Now this right here is what we call the confidence interval. You already know how to get P hat because I showed you how to get P hat. Now I'm going to show you how to find the margin of error. And once I tell you how to find the margin of error, you can do a confidence interval. And that's the MOE, M-O-E, margin of error. Make sure you write that down so you don't forget. Margin of error. Unless you're from around here, then it's error. Right? Margin of error, 1 syllable. And that's equal to Z sub alpha over 2. In other words, your Z-score, multiplied by the square root of P hat times Q hat over N. Or
God.
if you would like to do it this way, Z sub alpha over 2 multiplied by P hat Q hat over N raised to the 0.5 power. So let's talk about this. You have Z, you got that on the index card. You have P hat. P hat, you know how to find it. Q hat, you know how to find Q hat because P hat is usually going to be given to you. And N will be given to you. So basically, for the margin of error, what are you going to do?
Take square root.
Plug and what? And take the square root, yes. Plug and chug and take the square root. So let's do an example.
I love how you make it out to be so easy and it's really not.
So here's an example. With 204 employees, being sick out of 700 employees, find the confidence interval based on a 95% confidence level. Okay, there is the question. And the first part could be reworded. It could be, it could be anything. But it says with 204 employees being sick out of 700 employees, find the confidence interval based on a 95% confidence level. So let's write down what we have. We have P hat, 204 over 700. So I go to my handy dandy calculator. 204 divided by 700.
0.2914.
And that's equal to 0.2914. Now, since this is P hat and not an area, I'm going to, well, it could be. Oh, you could leave it as 2914. That's fine. 0.2914. Then take my pink one, minus 1. Minus 1, and there is 0.7086. That is your Q hat.
Why do you subtract 1?
It's the easiest way to do it. You don't have to do that. You can do 1 minus. It's the easiest way to do it. 0.7086. 0.7086.
Is the Q hat or just the Q?
Yep. Q hat. Remember, I told you it could be done 2 or 3 different ways, but in this book, it's Q hat and P hat. In the last chapter, chapter 6, we did P and Q. What else do we have? Somebody look up at the question. What else do we have?
95%.
95%. Go to your index card. What is the z-score for 95%?
2.05, 1.96.
1.96. Z sub alpha over 2 is equal to 1.96. And N is equal to 700. Now all you got to do is plug and chug.
So when you set up,
Here's the formula right here.
so 1.96 times 0.7086 times 0.7086. No, sorry, 291. All right, tore that up. Let's just try again. Mm, 0.7086.
Just hold off on your answer. Let's wait. Let's let everybody work on it for a minute. Okay, now I'm going to go ahead and do the inside. I want everybody to watch. Slide this over a little bit. So clear and clear. 0.2914 times 0.7086. And that's divided by 700. And raise that to the 0.5 power. Now I use 0.5, and I've been using that all semester. You can use the square root if you want to, however you want to do it.
Yeah, I
Times
totally screwed that up.
1.96. So I get a margin of error equal to 0.0337. Okay, so if you messed it up, go ahead and try it again. It won't be the first person that messed up.
Divide it by n. So oh boy. 1.96 times I don't understand how to do this. I'm trying to plug it, but I'm very confused right now.
Okay, tell me where you're confused.
P hat, which is
0.2914.
okay. 0.2914.
And then Q hat is 0.7086.
All right, that you divide by 700. So you do that first.
Yeah, you always do what's inside parentheses first. And then raise it to the 0.5 power.
Okay, so
And then multiply by 1.96.
0.5. And then multiplied by 1.96, and it's, what the hell?
Point
I'm not
zero
doing-
three three seven.
I do wrong. Oh my God.
All right, let's do it together. Watch me.
I'm used. I'm not gonna learn how to do it anyway.
Okay, let's go. 0.2914 times 0.7086. Tell me when you're ready to hit enter. You
I
ready?
got 0.206.
Okay. Now
Wow.
divide that by 700. Point
I
zero
got-
zero zero 29498005771.
Yeah, mine come up as a scientific notation.
Yeah. Now raise that to the 0.5.
0.0171.
And then multiply that by 1.96.
I can't.
Did you get it? Now you told me you got 0.01717. Did you get that?
Yeah.
And multiply it by 1.96.
Hang on, I'm trying to get this set up the way you got it because I'm not doing it right. And multiply that by 1.96.
Yep.
0.337.
0.0337. Yes.
All right.
Now, what do you have? You have the margin of error. Now, what do you do with the margin of error? Well, the margin of error is kind of like, I'm going to put it down here, and I'm going to put it in real light letters. The margin of error is kind of like you added your standard deviation. It's kind of like your standard deviation. Okay, you're going to add that to your p hat. Okay, so let me go to the next page. I'm going to write down what we have. Okay, here is what we have. We have p hat. We have q hat. We have z and we have n. Now, I'm going to write it in green because it's very important. The margin of error is equal to 0.0337. Now, where is the two most important numbers? Well, remember, up until today, your two most important numbers was mean and standard deviation. Now, it's p hat and what? Margin of error. Because they're going to act like the mean and the standard deviation. Except you're just going to write it over here. And I want somebody to put p hat right here in the middle. And over here, I want somebody to take 0.2914 and add it to 0.0337. And over here, you subtract 0.2914 minus 0.0337. Because what do we do on the right? We add. And what do we do on the left? We subtract. So on the right, we have, somebody tell me, point what? 3251? Somebody help me out.
.3251.
Thank you. and somebody subtract, I'm not going to try to do that in my head. Somebody subtract on the left.
.2577.
And that is your confidence interval. Okay, so remember when we started back in chapter 3 and we took the standard deviation and we added it on the right and we subtracted it on the left? You're going to do the same thing here. You're going to take the p hat and you're going to add it on the right and you're going to subtract it on the left. All right, who's got a question? Okay, we'll go to the next one. Let's go ahead and
Hold
work
on.
some problems.
So what we just did was the
Yes.
confidence identity.
This is the confidence level. I meant the
Level,
confidence
okay.
interval. I'm sorry.
Interval, yeah, that's what I meant. Okay.
This is right here, the confidence interval.
Okay.
And that is basically the whole question right here, except for this, which I went over to the side to show you how to plug and chug that. All right, let's do a nerd. Let's do some homework problems so I can get you as far as I can. Let's go to the homework.
This ain't 9.2, this is just 9.1. Still, we still
Yep,
have to go
this
over
is
9.2.
9.1. We'll get into 9.2 probably Thursday.
How are we supposed to review for the final?
That's what your tests are for. Hold on just a second. I didn't have it pulled up. I hate when it does that. There we go. And go to your homework. And I'm going to start with number 2 or the second one, because those are test questions. And there's only like, I think there's only like 10 or 12 questions. Yep. Well, there's not even 12. It's 11. All right. So question number 2. All right. So I'm going to pull up my handy dandy whiteboard. And look at there. 81. Did we do 81? I can't remember. No, we did 82. We did 82. So you got to do 81. What does it say? It says compute the critical value. And what does it give you? It gives you the Z that corresponds to 0.8100. So these are the ones we did before. So I'm just going to add 0.81 down here. 0.81. Somebody give me the complement of 0.81.
0.11 or
0.19.
0.19.
And what is 0.19 divided by 2?
0.095.
0.950. And somebody do the inverse norm of 0.0950.
1.
I heard 1 point.
1.310.
Okay, you broke up, Mr. Mance. It sounded like you said 1 point.
Well, 1.310.
1.31. Is that what you said?
Yeah, 1.310.
Okay, 1.31. Remember, z-scores are only to the second decimal point.
Okay.
All right, who has a question? There it is, right there. So 1.31. That is a test question. So I'm going to leave that up for a second just so you can see it. There it is down at the bottom. They gave us 0.81. P is 0.19. I'm sorry, alpha is 0.19. Take 0.19 and divide by 2 and get 0.0950. And that's 1.31. Okay, let's do another one. All right, try this one. It says compute the critical value. I'll blow it up here a second. Hold on. I'm sorry. No, it won't let me. I can't blow it up. Compute the critical value that responds to the 82nd. Oh, well, we've already got this one. Go ahead and write it down, but you've already got it. It's right there. 82 is right there. We did that one a while ago. 1.34. So I'm going to type that in because we already had that one. Should you keep this for the test? Yeah,
I would.
because they've already asked for 2 that's on this one. So 1.34. So that's 2 test questions right there that you could do right there. And I'll probably give you several of those to make you feel good. All right, write this one down, and it won't let me. Let me see if I can blow it up here. No, it won't let me. I don't know why I can't blow these up for y'all. It won't let me do anything. All right, write it down. It says, determine the point estimate, the margin of error, and the confidence interval for the following numbers. That's basically what it says.
Does it say?
I'm going to write it. Hold on. Give me a second. I'm getting there because I can't blow it up. Okay. The lower bound is 0.9096. The upper bound is 0.474. And N is equal to 1,000. I'm going to put that down here. Now, what they are doing right here, you need to write this down. They are giving it to you backwards. Okay? Let me show you what I'm talking about. Y'all remember when we did the confidence interval a while ago?
Uh-huh.
And we got this? Everybody see that right there? Tell me what this one is right here. Is that the upper bound or the lower bound?
Lower.
Low bound.
Good job. That's the lower bound. So write that down. Now, if that's the lower bound, what do you think this one is?
Upper bound.
That's the upper bound. So now you know what the upper bound and the lower bound is. So let me ask you a question. In this problem, we found the margin of error and we found the confidence interval, right? Does everybody understand that? We did this and we came down here and we got the confidence interval. What does this one say? This one, they give us the confidence interval and we have to what? Find the rest of the stuff. Do you know what we're going to use here? Something that all of you know how to use. How do you do the mid-range?
Lower.
Somebody tell me, how do you do the mid-range?
You add them together.
Yeah, thank you. The high plus the low and divide by what? 2. And that will give you this right here that you learned back in chapter 2 or 3. It will give you your p hat. So I want y'all to put in your calculator 0.096 0.096 plus 0.474 and divide that by 2 and give me 3 digits, please.
.285.
And that is your mid-range, which in chapter 9, your mid-range is also can be p hat. So that goes in the middle. Now let me ask you one more question. If I can put 0.285 in the middle, can somebody tell me the margin of error? If 285 is in the middle, right here, can somebody tell me the margin of error? Yes or no? You got a 50-50 shot. Whew. Okay, I'm going to ask one more time. If I have P in the middle,
Priority 1 message coming in on secured channel.
and I have an upper and a lower bound, can I find my margin of error?
Yeah.
I heard,
I said, yeah.
good job. So that is, how, so can somebody tell me how I can find my margin of error from here or from here? You can take your pick. Somebody tell me, how can I find my margin of error from these numbers?
Add or subtract.
Add or subtract. Tell me which one you want to do, Mr. Mance.
You can add.
Okay, so I think subtraction would be easier. 0.474 minus 0.285. Somebody do that one. Or I could take 0.285 and subtract what?
Well, the first one is 0.189.
Okay, 0.189. And somebody give me the second one.
Is it also 0.189?
Exactly. So what's the margin of error?
189.
The margin of error, good, is equal to 0.189. Now write that one down because, now how do you know the difference between this one and this one? Well, you got to read the question. The question starts out with a lower bound and an upper bound. The lower bound and an upper bound, they're giving you the confidence interval, and you got to back it in. Now, this is nothing but 100% math. I meant basic math. The only formula is your mid-range formula that you learned back in chapter 3. All right, so let's type those in. The point estimate is 0.285. And the margin of error is 0.189. The number of individuals in the sample with the specified characteristic, you're going to take n and multiply it by p hat. So if somebody, at 3 places, that'd be 285 people.
What was the question though? The number of the what?
The number of individuals in the sample with the specified characteristics is, and you're going to multiply p hat times n. And all you got to do, since n is 1,000, you move the decimal place 3 places to the right, and that's 285. Let me ask you a quick question, right quick. I'm gonna drill you. Right quick, chapter 6. How did you find the mean given N, P, and Q? How did you find the mean given N, P, and Q? There's the mean and the standard deviation. How did you find it?
Oh, no, I couldn't do that either.
How'd you find it?
Square root is NP times
Q.
Q.
And what is the mean?
N times P.
I thought you said you didn't do it.
I can't do it on the test.
Yeah, you did. You got several of those right. Okay, now, what is this right here? Back here, what is this? Oops, that's not the question we were on. Okay, somebody tell me what this is. The point estimate, that's P. And what's this? N. So 1,000 times 0.285. In other words, have you done this before? Yes, you've done it before. You've taken 1,000, which is N, and multiplied it times P. So mu is equal to 285. Okay?
I didn't get that wrote down.
Okay. There you go. Which this is nothing, this is from chapter 6. What I'm trying to show you is this problem that we're doing, all you do is take N times P hat, and that's your answer. I just wanted to let you know that y'all have done it before. Okay, next question. All right, I'm going to let y'all do this one. I'm going to let y'all work on it because it says construct a 99% what? Confidence interval by given X is equal to 40 and N is equal to 200. Well, heck, that's just like this one. That's just like this one, and I'm gonna put it on here for you. You got your index card, just like this one. So I'm gonna let you work this one. And somebody look on your index card for that 99% Z-score.
Is that X is equal to 40?
Yes, X is equal to 40 and N is equal to 200. So the first thing you do is you find P hat. Just like I did. Somebody tell me what the Z-score is for 99.
2.58.
Good job. So you got your Z-score, 2.58. I'm just going to mark through this because I'm just trying to help y'all get started. What'd you say, 2.58? And this is going to be 200 over, 40 over 200. And that's 40 over 200, so that'd be 0.2. Somebody check my math. And if P hat is 0.2, somebody tell me what Q hat is. 0.8. Did somebody check me what's 40 over 20 or 40 over 200?
How did you get 4.8 on the P hat?
It was 2.2.
The
0.8.
complement of 0.2.
Okay.
Did somebody check 40 over 200?
Yeah, it's 0.2.
0.2.
Okay, the only thing different is N is equal to 200 here. So I'm going to change that to 200. So I can get to work now. So I'm going to rewrite everything over here for you. So X is equal to 40 and N is equal to 200. P hat is equal to 40 over 200, which is equal to 0.2. Therefore, the complement of 0.2 to a whole is 0.1.8. So therefore, P hat is equal to 0.8.
Q hat.
Oh, sorry. Thank you. Okay. I'm glad somebody's paying attention. All right. So now N is equal to 200. And what do we say Z sub alpha over 2 is? 2.58?
Yep.
Okay. Margin of error is equal to 2.58 times 0.2 times 0.8 divided by 200. And I'm going to use 0.5. And you can use square root if you want to. And I just plugged and chugged. Well, I found out today that one of the classes I was telling you about started with 30. Guess how many they got in it now? 3. So I think we're doing pretty good.
What happens
We
when
started
you,
with 10 and got 8.
what happens when you get a scientific notation every time?
You just keep going. You got, in other words, here, let me show you. 0.2, I'm gonna clear it. 0.2 times 0.8 divided by what? Divided by 200. You just hit the caret symbol, 0.5. Did you get 0.0283?
Yeah.
And then multiply that by 2.58. I got 0.072, well, 0.0730. Y'all get that?
Yeah.
0.0730, which is 7%. You got a 7% margin of error. So now all you got to do is set up your interval. So p hat is in the middle. And you're going to have some numbers here and some numbers here. So I'm going to go ahead and add it. Where is 0.2? So 0.2 plus 0.0730 and 0.2 minus 0.0730. And I need somebody, I can do this. This is 0.2730. And somebody subtracted on this end for me. 0.2 minus 0.0730.
Negative 1.5083.
It's not going to be negative. It's 0.2 minus 0.07530.
127.
127. And there is your confidence interval.
What's that today?
Say again, Mr. Mance.
Oh yeah.
So let's go over it.
Yes, I am.
You were given this right here. Here's what you were given. You were given this right here, and you were also given a 99% what? Confidence level.
Confidence.
And that told you what to look up on your index card. So all that was given. First thing you did is you found what? P hat. Second thing you did is you found the complement. Third thing, you looked up your index card. And the fourth thing is you wrote down N just so you'd have it. And those 4 things go where? Into your formula. You plug out, and then you add it on the right and subtract it where? On the left. And I circled these because I'm adding this to that right there, and I'm subtracting this from that right there, just like the standard deviation. And that's your confidence interval. Okay, let's see. All right, So we've got you, let's see how far I went in the homework. I've already done half your homework for you. I've done 5 out of 11. You are welcome. Okay? All right, let's shut her down. See y'all Thursday, and we'll finish this section and go over 9.2.
Did you cut out chapter 10?